So we've got a little algebra to review today, as well as some work with our calculators. We're going to start off with the distance midpoint formulas. They're written right in front of you. Pretty common concepts. Remember, the distance formula is going to come from just a Pythagorean theorem based on 2 points. So if I have a point here and a point here, call this some x1, y1, and then call this some x2, y2, and I want to find the distance between those 2 points. Then I draw a little right triangle, and then I take the difference in y's, so y2 minus y1, square that because it's one side squared plus another side squared, and that other side is going to be the difference of x's, and that's going to equal your distance squared. Square root both sides. There's your formula. Midpoint is just halfway between the two x's, so I take an average of those two, and halfway between the two y's and take the average of those two. So let's take and find a distance. Pretty standard problem. We're going to take the difference of x's. So I've got 3 minus a negative 2. I'm going to square that. Add that to negative 5 minus 7. We're going to square that. This gives us 25. This gives us 144. So we have a total of 169, which happens to be a perfect square, or 13. So there's our distance. If I want to find the midpoint, again, I'm just going to take the average of those. So the x midpoint is going to be made up of 3 plus negative 2 over 2, and the y midpoint is going to be made up of negative 5 plus 7 over 2. In this case, we have 1/2, and in our second case, we have 1. So there's your midpoint. Next, we're going to want to determine if some points lie on a graph of a line. Now, we don't commonly graph functions like this, but we don't have to necessarily be able to graph it to determine if the points are on the line. If the points are on the line of that function, then both the x and the y will satisfy the equation. So all I have to do is plug them in and check to see that I get my y value after plugging the x value in. So let's do that in the first one. I plug in the point 1, so I have 2 times the cube root of 1 plus 1 squared minus 1. Hopefully that's going to equal 3. This ends up being 2 plus 1 minus 1, which ends up equaling 2, so no, that doesn't work. Let's try the next one. I'm going to plug in negative 125, so I have 2 times the cube root of negative 125 plus negative 125 squared minus 1 is supposed to equal y. In this case, I have 2. Cube root of 125 is negative 5 plus, well, this guy's just big. I'm just going to put big because I don't want to calculate it. And there's no way that's going to equal negative 2. So this is a no as well. So hopefully this last one works, but we'll check it out anyways. We've got a 2 cube root of 8 plus 8 squared minus 1. 2 times the cube root of 8, which is 2, is 4, plus 64 minus 1. That's going to equal 67. So yes, that point is on the line. So 8, 67 is our guy. Intercepts. Any graph, I don't care what it is, if I have an x and a y-axis, and I have any graph. Let's say it's a graph like this. All right. No matter what, where it crosses an x-axis is your x-intercept. So this is my x-intercept, and wherever it crosses that axis, we notice that all points on that axis have a y value of 0. I don't know what the x is going to be. Likewise, for a y-intercept, any point that crosses the y-axis is going to have an x-coordinate of 0. So if I want to find any x-intercept, I basically set y equal to 0. And if I want to find any y-intercept, I set x equal to 0. So we'll go ahead and find an x and a y-intercept for a standard line. Basically, x-intercept, set y equal to 0, so I have 4x minus 7 times 0 is 14, leaving me with 4x is 14, or 7 halves is equal to x, and that's my x-intercept. For my y-intercept, I'm going to set x equal to 0, so I have 4 times 0 minus 7y is equal to 14. Negative 7y is 14, so y ends up equaling negative 2, and that's my y-intercept. So now we've got a situation where we have a graph that we're not very familiar with. We don't typically graph x-cubed graphs, and what we want to do is we want to find the intercepts of this graph. Now, in order to do this, we're going to use a calculator. So we grab that and turn it on, and we've got something like this. And what we're going to do is we're going to hit our y equals button, and if you've got something in there already, just go ahead and hit clear, because we want that to be fresh, and we're going to plug in the following function. We're going to plug in 3, hit the x, and then in order to raise that to a power, we're going to use this little caret button to the third power, minus 4y. But the problem is, in this case, there's no y's, so we can't really do it in the form that it's in. So let's go ahead and clear that. Let's go back to our equation and take and solve for y, because that's how it's set up in our screen for our calculator. So we go through and we say, alright, I've got 3x cubed plus 8x squared. I'm going to take and subtract 5 from that and set that equal to 4y. Then I need y by itself, as we stated. So we say y is equal to, I could divide this whole thing by 4, or I could multiply by 1/4 to the entire equation, which I think I'm going to do. So I've got 1/4 times 3x cubed plus 8x squared minus 5 is equal to y. And now we'll go back to our calculator and we'll plug this in. So if I want to plug in 1/4, I can either plug in 0.25 or 1/4. I'll just do 1/4 in this case. But whenever I have a fraction, I want to put the whole fraction in parentheses. So I go 1 divided by 4, close my parentheses, and then I'm going to open up another set of parentheses, and that'll tell me to multiply. So I've got 3x to the third plus 8x, and for squared I can just use this button right over here, minus 5. And now I'm going to ask the calculator to go ahead and graph that, because again I want to find my intercepts. So when I graph this, well, let's make sure we're all looking at the same thing. Hit zoom, and then we're going to hit 6 for standard, and that graphs it from -10 to 10. Let's see what I end up with. So in this graph we can see that I have a y-intercept, but in this case I actually have 3 x-intercepts. So we're going to go ahead and find all of that. Now the way I like finding x-intercepts is maybe different than some of you have found it in the past. I like finding out when y is equal to 0. So what I do is I go back and I graph a second graph. I find y equals 0 and ask it to graph that. And you really won't be able to see it because it's on the axis, but we'll use that real quickly. I want to calculate where y equals 0 is equal to this graph. So that's 3 different points. So what I'm going to do is I'm going to find 3 different intersection points that will tell me where the x value is at the point y equals 0. So what I'm going to do is I'm going to now go second and hit the trace button, which is calculate, you'll notice. And I'm going to find an intersection. So I'm going to hit 5. So next, you see this little blinking dot over here? I want to take that and bring it close to my first intersection point, which is right around here. And then I'm going to hit enter 3 times. 1, 2, 3. And what it'll do is it'll find this first intersection. So it looks like my first X-intercept is roughly negative 2.37. So there's 1. Let's go back to our calculator again. I'm going to find the next intersection point by again going calculate the intersection. And this time I'm going to make that blinking dot go close to my next intersection and hit enter 3 times. 1, 2, 3. And it ends up being at negative 1. So I'll put another one right here of negative 1. Let's find the third by again going second calculate and moving to intersect, getting the blinking dot to come over here and hit enter 3 times. And the last one is about 0.7. Now unfortunately, the calculator won't graph a vertical line because it only graphs functions, and we know vertical lines aren't functions. So what I've got to do is I've got to look at my table to find out what the y value is when x equals 0. So here's what I'm going to do next. I'm going to go second, table, and right now I have my table set up in a special way. Let me show you how to get to that. We're going to take and go second, table set, and you can start your table anywhere you want. Mine started at 700 for some reason, but you don't have to start there. And delta table, that means how much the increments go up by is 50. But the important thing here is I have my independent variable, which is x, set to ask. And what that allows me to do is plug in any number for x, and it gives me a y value. So that's kind of what I want to do. I'm going to go back to table now. And I can clear this number here if I'd like, or delete it out. And once I do that, then I can plug in any x value like 0, and it'll give me the y value associated with it. So I'll hit return or enter, and it gives me a y value of negative 1.25. So I have y-intercept of negative 1.25. And that's how you use your calculator to find the intercepts of functions that you couldn't normally graph or easily solve for. Because once again, in this case, solving for y is pretty easy. Setting x equal to be 0 would be easy, but if I had to set y equal to 0 and solve this cubic function, it would have been kind of tough. Right? So you're going to go out and fill the form out and then go to my math lab and do the couple of problems I assigned for tomorrow.